Today we will do volumetric analysis. In the regular classes, that is in the academic classes, we have done it the volumetric analysis, that is your molarity, normality and all those things. But here we will be dealing with a particular, what you can say, thing, that is titration. Titration. Now you do not know what is titration. So I am going to start with that, titration. Write down the definition, titration first. Titration, the process of addition of the known solution from the burette. The process of addition of the known solution from the burette to the measured volume of solution, to the measured volume of the solution of the substance to be estimated, until the reaction between the two is just complete is called titration. Until the reaction between the two is just complete is called titration. Now, titration involves two types of solutions. One is unknown solution, another is the known solution. One is unknown, another is the known. Now, generally you see when you do titrations, this is, we take a burette. We take it. Here a stopcock is there and the marking is there. This is known as burette. Alright? I'll send a video regarding this titration. Now, next is we take a conical flask. We take a conical flask, which is also sometimes called as a titration flask. This is, we take a conical flask. We are having a stopcock here. A stopcock is present here. Here a stopcock is there. Okay. So this is stopcock, and drop by drop the liquid falls in this particular, what you can say, titration flask, and we are filling it up to 0. This is a 0 mark. We are filling it up to this, we can say. So basically what you find is that this particular solution which is there in the titration flask is the unknown solution. Unknown means whose concentration we have to determine. This is your unknown solution. This one, unknown. This one is your unknown solution, we can say that. And this is your known solution whose concentration you know it. You know it generally. The concentration you know. So this is your burette. We are having a stopcock. You open the stopcock so that drop by drop the solution falls into this titration flask. In the titration flask, which is a conical flask, in the titration flask we are taking a solution which is the unknown solution, whose concentration we do not know, which you have to determine it by this process of titration. By the process of titration we determine it. Okay. Now, what we have to do before titration, I will tell you the process. Now, just this is a thing. Now, how do we take this particular solution in the titration flask? How do we take it? The solution, the known unknown solution, how do you take it? Now, we are having another apparatus. This is known as a pipette. We are having another apparatus. This is called as a pipette. Another apparatus we are having it. That is this sort of long mouth. Okay, this sort of long mouth. A marking is being present here. A marking is there. Up to this marking, we have to suck it. Now you have to put your mouth into it, and you have to suck the liquid from a particular beaker or in a conical flask, whatever is being there. You will suck the liquid. Up to which level you are going to suck it? You are going to suck it up to this particular level. You are going to suck it by the help of the mouth. You are going to suck it. Which is this called? This is known as what? Pipette. This is to be as. You will see in the lab. When you will go to the lab, you will see it in the lab. Or you might have seen it also. This is a pipette. This is a burette, which consists of this stopcock. You have to fill it up to 0 mark, and then drop by drop you have to allow it to fall into this, what you can say, titration flask. So what you will do is that you will suck the solution, and where you will put it? You will put it in this titration flask. Got it? The solution which you can see, the unknown solution, you can see. How did you get it? By sucking it by the help of the pipette from another vessel. You will suck it and you will put it in the titration flask. Generally, the pipette is coming in the size of 5 centimeter. That is 5 centimeter cube, 5 ml, or 10 ml or 20 ml or 25 ml. Different sizes of pipette it comes according to your need, according to your use. Okay, clear? Now this is what you can say, pipette and burette and all those things we came to know. Now what I say, an unknown solution and a known solution. Now next you write titrant. Titrant, give heading T-I-T-R-A-N-T, titrant. The reagent or substance, titrant. The reagent or substance whose solution is employed, the reagent or substance whose solution is employed to estimate the concentration, of unknown solution is termed titrant. To estimate the concentration of unknown solution is termed titrant. Generally what we are taking in the burette, that is called as titrant. Because this is the unknown solution, this is known as titrant. Now this titrant are of two types. One is your primary titrant, another is your secondary titrant. Write down. First one, primary titrant. Primary titrant. These reagents can be accurately weighed and their solutions. These reagents can be accurately weighed and their solutions are not to be standardized. Before use. Example, oxalic acid, potassium dichromate, silver nitrate, copper sulfate, etc. Secondary titrant. These reagents cannot accurately, just opposite of primary titrant, okay? These reagents cannot accurately weighed and the solutions are to be standardized before use. Example, sodium hydroxide, potassium hydroxide, hydrochloric acid, etc. So in case of primary titrant, you see already it is standardized. Alright, we know the weight of the particular substance. But in case of secondary, we do not know, we have to accurately weigh it and it needs to be standardized. Standardized means what? Whose solution, whose concentration, we know it. That's called as a standard solution. Alright, standard solution I told you. Which solution is standard solution? Whose concentration, we are knowing it. Okay, once again I will tell you. Right now, standard solution. Standard solution, write the definition. The solution of exactly known concentration. The solution of exactly known concentration of the titrant. Yeah, this is known. Concentration of the titrant is called the standard solution. So again I repeat, in the burette which you are adding, it is a titrant in the burette which you are adding, which is known to you. Either it can be primary or secondary. Primary, it is already standardized. Secondary, you need to standardize it. You will be standardizing it. Okay. Next is titrate. Here, this is called titrate, which we are adding it to the conical flask. This is your titrate. Alright. The solution consisting the substance. To be estimated is termed unknown solution. To be estimated is termed unknown solution. The substance is termed titrate. Definitely. We have to know the concentration of this unknown solution. So this is known as titrate. Next, equivalence point. Equivalence point. What I said? Equivalence point. Now listen, before telling the definition, listen what I am saying. Equivalence point. Now listen here. This is your known one. So you'll put it up to 0 mark. Anything. Suppose you are taking here NaOH or anything you are taking it. Alright, the known concentration, and here this is an unknown one. Let us say you are taking here oxalic acid or sulfuric acid or anything you are taking. This is an acid-based titration I am saying you. Alright, so here I have taken a base and here I am taking an acid. Let's say, and you will be putting a indicator also. 2 and know whether the reaction is complete or not. Alright, indicator you will be using it. That I will say you later on. One by one I will say you. Don't worry, I will say you. Indicators. So basically indicators are phenolphthalein, methyl orange. We are taking it as an indicator. Phenolphthalein, methyl orange, we are taking it. So this indicator will be adding it. Which indicator you have to add it, that also I will tell you. Don't worry. So you will be adding an indicator. Why we need an indicator? Because indicator will indicate whether the reaction is completed or not. Why? Because suppose I take here NaOH. What is the color? Colorless. Suppose I take here HCl. What is the color? Colorless. NaOH plus HCl, when it undergoes neutralization, what it forms? NaCl and water. What is the color? Colorless. So how do we know that the reaction is complete? So for that reason we need to add an indicator. The indicator will indicate the end point of the titration. End point means where the reaction gets completed. How do we know that the reaction has got completed? So for that reason we need to add an indicator. And end point is also otherwise called as equivalence point. It is also known as equivalence point. Understood what I said? Suppose we'll take here NaOH and we'll take here HCl. We'll allow NaOH to drop upon the HCl drop by drop. At a particular point you will see that the titration is complete. And when it will be completed? When the solution get neutralized completely. When the solution gets neutralized. How do we know that the solution is neutralized? Because all are colorless. Generally the solution we take it as colorless. So how do we come to know the solution has got neutralized? For that reason we need an indicator. So we add an indicator to this unknown solution, to the titrate. We add an indicator before the experiment. Now when the experiment will get complete, when it will reach equivalence point, when it will reach end point, the indicator color is going to change. So at that particular point, the reaction gets completed and we stop the stopcock. For that reason I am sending you a video. I told you where the process of titration is being shown. You will see the video, you will understand it completely. Alright, so write down the definition, equivalence point. The point at which the reagent, titrant, in bracket you write titrant, the point at which the reagent, in bracket you write titrant, and the substance, this is a reagent, titrant, and the substance, in bracket you write titrate, under investigation, are chemically equivalent. Under investigation are chemically equivalent is termed equivalence point or end point or stoichiometric point. Equivalence point or end point or stoichiometric point means it indicates when the reaction gets completed. It indicates when an acid is being completely neutralized by a base, when the titration gets completed. Alright. So in this way that is said to be as the end point. Last one, indicator. Let's write the definition. Indicator. It is the auxiliary substance used. It's an auxiliary substance used for the detection of the completion of titration. For the detection of completion of the titration. That is, it detects the end point of the titration is termed as indicator. Thank you very much.